Hello, this is Gary Marr from Arizona State University. This screen capture is for my IFT 101 students. In this screen capture, I want to expand upon some topics and concepts covered in Module 3 of our Canvas shell, and material that was covered in chapters 4 and 5 in Sprinkle and 2 and 3 in Severance. So, having said that, what I've done is this. In Modules 1 and 2, you have a set of PowerPoints that I created. The PowerPoints, some of them come from Sprinkle and Hubbard, some of them are my PowerPoints. And when I taught this class in the spring, I put the PowerPoints together, and from those PowerPoints, I created video, which is still out there for Module 3. Now, in Modules 1 and 2, I updated the slides so it says in the beginning, the very first slide, fall instead of spring, but the material is the same. So what I decided to do is, rather than repeat myself on the PowerPoints and then the video that came with it, that I would create another video or additional videos as the semester went on that would expand upon some of the material covered in those PowerPoints. So what I did in this video is I took a spreadsheet, and in that spreadsheet, let me bring it up for you, I created 5 worksheets. The first one has a pack diagram, the second one has an interactivity diagram, an IPO, pseudocode, Python. So as you click on those tabs, you'll see different information. Now, this spreadsheet's been stored in Canvas. If you go to Canvas, Files, Module Resources, Module 3, you'll find the spreadsheet. You can grab it. In fact, you can use this spreadsheet to answer your questions for the assignments also, because you're going to be asked to create pack, interactivity, and IPO charts as the assignments continue. But what I did is I created an example. It's a simple example. It's probably an oversimplification, but at least lets me walk you through from the start to finish how you would use these models to create code. So for this particular example, you're a programmer that works for a company that has a fleet of vehicles. And these vehicles have to have the oil changed in them. So what you've been asked to do is to create a program that takes the mileage from the last oil change, the mileage of the truck currently, the vehicle ID of the truck, and then calculate based on some logic whether or not it needs an oil change. So the very first diagram, the pack one, accepts original mileage, new mileage, vehicle ID as inputs. The results needs to know whether this program should determine whether or not the oil needs to be changed. And in the processing, it's going to say if the mileage difference is more than 3,500 miles, then you need to change the oil. Okay? If it's less than that, then the oil is okay. Now, this is a simplification. There's some other logic that would have to be included in here based on maybe the entry of invalid data. There's no really data checking in here, but hopefully this is enough to at least kind of walk you through the entire process. The alternatives, I have a couple alternatives. I could do processing of one truck or one vehicle or multiple. I could also, instead of using 3,500, I guess I could have that input into the program as it executes. I've decided not to do either one of these two. It'll process a single truck, not multiple trucks, and I've set the oil change parameter or threshold to be 3,500 miles. The interactivity chart shows the relationship between the modules, and what I've decided to do is call my modules input, processing, output, and output also has a module called to print. Now you're going to find that as I get into my Python examples, I've changed this a little bit, but at least for now this is fine. It shows a relationship between the main program and the calling of the modules. On the input-output diagram, I'm going to show the input, the processing, but very important here, I'm going to show the relationship between the modules, the module reference in the IPO chart, and also the modules over here in the interactivity chart. As far as my pseudocode goes, I'm going to pull this from the required processing piece of the pack. I'm going to add start and end, so it's true pseudocode. And then you can also see some indentation and formatting of some of the logic in this model. That's where the pseudocode comes in. But this cannot be executed. I mean, this is just a plan, just a map, if you will. The part that can be executed is the Python. So what I did here was I took the pseudocode that I created in this step, I copied it over to the Python piece. Some of the pseudocode that I wanted to keep as comments or program documentation, I started off with a hash symbol or pound symbol. So the processing, the output in the end simply was a reuse of some of those labels that were in my pseudocode into my Python program. Now, this program here wouldn't run from Excel, but I do have the program set up to run in a Python IDE. I'm going to show you how to use Sony. Now, you can use Sony, you can use idle, you can use anything you want to process Python. There's a number of options. The two simplest are probably idle and Sony. Idle's okay, but Sony is written specifically for Python. It has a very nice debugger in it, and it's really designed for people to learn how to use Python. There are other options beyond this. I mean, you can use Visual Studio Code. You could use Visual Studio. You could use, there's numerous Python IDEs. Whatever you want to use is okay, but I'm going to show you how to use Sony and the Severance book, and also some of the stuff, I believe. No, in the Severance book, they do show you how to use idle. All right, so let's do this. I'm going to now bring up my Sony screen. Sony is a program that, again, is written, it's a freebie. It runs on Linux, Apple, and Windows, and it's written specifically for people learning how to program in Python, or new programmers. The way this is going to work is I'm going to, again, take my pseudocode, make my comment symbol in front of the statements that will not execute. My identifiers will be up front here. I've got one identifier here I'm creating right off the bat called change oil using camel casing. And all camel casing means, again, it's lowercase, and then any following words in an identifier name are going to have a capital letter, so it's like a hump on a camel. This one's going to be set to a string variable or string literal of no. I'm going to have two Python instructions which are going to ask for input, and they're going to show a prompt on the screen that says enter original mileage and a new mileage. It's going to convert those numbers to integers. Now, by default, input will take that keyboard input and convert it to a string. String cannot be used in calculation, so I've got to make it a number. Now, I could make this floating point, but I've decided that the people using this application don't need to worry about decimals. They're going to use just integers, so I convert the input from string to integer. So now I have a variable called old mileage and one called new mileage, each having some number in it representing when the last oil change took place and what the mileage on the vehicle is now. I also ask for a string value. This is not used in the calculation. So this one just has an input function and no case conversion, or data type conversion, to either int or float. It's just going to be text. What you'll notice with Sony and most of the IDEs is it has syntax coloring. Your identifiers will be white. Your reserved words or keywords in Python will be light blue. String literals will be green. Numeric literals will be orange. You typically have control over what colors you want to use here. You can also do theming in most of these programs, which someone's already come up with colors that are done by someone who's much better with colors than I am, and aesthetically very pleasing. I typically use the blue background, white foreground, because that seems to be easiest for my students to see either online or in front of a data show. So anyways, this is my start, and it's also, if I wanted to, I should probably put another comment here, that this is the input part of my program. Okay? The processing part would be the calculation necessary to determine mileage. Okay, and this would be the new mileage less the old mileage. The result of that goes into a new variable I'm going to create on the fly called mileage. The next thing I want to do is I want to test to make sure that mileage, if it's greater than 3,500, changes the oil. Now, what Python does here is a couple things happening. First of all, keyword is, reserved word is in purple this time. It's not a function call like input and int, which are built-in functions. This is actually a reserved word. You'll see that the Boolean expression is right here. It's my two tokens, and it's got a logical operator in between. The colon is important. That marks the end of the if piece of this block of code, so that when the Boolean expression completes, what is directly below it will be the true branch. This currently has no false branch. Okay, I believe I had that in my pseudocode, but I did not implement it here. I figure we'll talk about it some. It'd be good learning to see that it not being there too. The false branch is optional. It does not have to be there. So the true branch would execute. And one thing you'll notice here is that the true branch is indented, probably too much. It's a little too far over. But with Python, there's a couple things you have to watch out for. It's case sensitive, first of all. So be careful when you name these things, that if you're going to use camel casing, that you're consistent when you call it again. Otherwise, it won't find it. When you indent a line of code, it usually belongs to a block of code that's associated with either a module or an instruction. In this case, if, which happens to be a decision data type. Or excuse me, a decision structure. So the true branch will execute change oil. It'll make that equal to yes. So what was no now becomes the word yes. And I can probably make that capitalized to make it consistent. And then finally, I've got another comment here indicating that the end of my program, or the output, is going to use a built-in Python function called print, which is like input and int. It's built into Python. That's why it's light blue. And what it's going to do is print a text literal, which is just text. And then next to it, and that's what the comma means, it's going to join it to a variable in change oil, which is going to be either yes if it's needs an oil change, or no if it doesn't. And then another string literal, which is going to print some more information for truck. And then finally, it's going to print the truck ID after that. Now, the way all of these interpreters, or excuse me, all these IDEs are going to work, because they're interpreters, is that you're going to have a code window. And then when you run the code, which is this VCR button up here, I'm going to see in the shell window the running code. So there's my first prompt asking for my original mileage, which I will say is 500 miles. It'll ask me for my new mileage, which I'll say is 5,000 miles. Now this should meet the threshold for an oil change, correct? Because it's more than 3,500 miles. So when I enter, I got to put the truck ID, it's truck number 6. And then finally it's going to tell me oil change is yes for truck number 6. So that's the first test. Now I'm not done. One of the things that happens here is you don't think like a machine. And even though you think you may have all the instructions very specifically laid out, you're going to find with testing that you may have missed something. These are called logic errors. Syntax errors if you spell something wrong. So for example, if I put, instead of int, I put in the word integer, I'd probably get a syntax error. Okay, so your syntax errors. Logic errors is when you make a mistake designing the logic. And a runtime error would be caused when you get a do not compute scenario. So for example, if I forgot to put the int in front of input on old mileage, it would be a string. If I try to do math with string, new mileage minus old mileage, and old mileage is a string, the computer is going to say, thanks for playing, but this doesn't compute. I can't do math with numbers and letters. So the program just stops. It's a hard error. You're typically going to get a red circle with a white X in the middle. So 3 types of error. Syntax, which means you've messed up your typing here and typed one of the instructions wrong. Logic, which means your statements aren't complete. You haven't put enough information or the correct information to get the good answer. And that's what testing helps you find. And then finally, runtime errors. And that's the common thing there is trying to divide by 0, which can't be done, or when the calculation doesn't make any sense. That's 2 very common ways to get runtime errors. You'll see more of those as we get into other topics in class. So what I want to do now is test this again for a truck that doesn't need an oil change. The original mileage is going to be 1,000 for this truck. Its new mileage is going to be 2,000. It's going to be truck number 7. And it's going to say it does not need an oil change, which is consistent with our logic because we said, based on the business rules, that a vehicle had to have more than 3,500 miles. Now, what you always want to make sure you do is in your Python code, you want to comment those parts of the program which may be confusing for someone else to look at, or maybe if you're going to look at it later, another year down the line. So what I might want to put here is a comment that says, oil changes are done with trucks with 3,500, and you can make this as long or as short as you want. This is getting kind of long. I'd probably make it shorter otherwise. Miles. And you could say since last change. With programming languages, typically your comments would be directly before the line you're commenting or to the right of the line you're commenting. So this one, this statement here are before the block of code it's commenting on. This one is commenting specifically this particular line of code. All right, and I could also say, and this one is a calc for mileage. It's pretty obvious from the statement, but I could still put that in there. And comments are not executed by the program. They don't make it run slower. It still runs well. It's just there for either someone who has never seen this program before and has to maintain it, or if you were to go back to it, a couple months later, if you left comments in there, maybe a tricky part of the code would be better spelled out if you had put something in there to describe what was happening in that part of the code. All right, so that's that part, and that's that Python program. The other thing I did was this, and again, I'll have to warn you, I ended up not using the module names that I defined in my interactivity chart, in my IPO chart. I varied a little bit. I went more descriptive names. This program is the same program as I just showed you, but with modularization. So I have a module called input mod. I have a module called processing. And let's do this. Let's make it consistent. Let's call this processing mod. And then I have one here called output, which is now going to be called output mod. All right. And that's all the modules I have in this particular example. Now I just made some changes here, so I have to make sure I make the change in the other statements. And this one's going to be output mod. And the way this program is going to flow is such. Modules, well, the first executable line of code is actually here on line 3. It's going to set up a global variable. Oh boy, that's not how you spell initialize. I'm going to call this just global variable. And that's also something covered in the sprinkle readings for 4 and 5, called truck ID. Then I'm going to have a block of code that's identified with a module called input mod. Another block of code which is associated with a module called processing mod. Another one with a block of code that's associated with output mod. So I have one identifier, 3 modules, and when Python takes this code, it stores an empty string inside truck ID. It puts input mod, processing mod, and output pod in memory. It doesn't do anything with them until they're called. The first executable line of code in this program is on line 30, which says execute input mod with no arguments. So if I go to input mod, it's not expecting any parameters, so that's all golden. I'm not passing anything to it. The way that Python handles global and local is that if you want something to be global, you would define it outside the module, but you would also use the global keyword to identify it if you're going to use it within a module. So I'm going to use truck ID in all of these modules, I believe, at least 2 of them. So I'm going to say when it comes to truck ID, I want to use the global version. If I just try to use truck ID on its own, it'll think it's local to this module, and therefore when I want to reference it in a different module, that reference will no longer be there. Okay? So it's going to have a global variable called truck ID, identifier called change oil. This is right from the other program I created earlier. This is the same from the other program. These are all coming from this first version of Python that I had. And then down here what I'm going to do is make a call to the processing module, and I'm going to pass it 2 pieces of information that were local to this module, the new mileage and the old mileage. I'm going to send those data pieces that are local here to my processing mod, which is expecting 2 parameters. They have to be in the same order, otherwise they're not going to come in correctly. I'm going to give them different names, old mile, new mile. So if this was 1,000 and this was 500, there'd be 1,000 stored here and 500 stored here. The next thing I want to do is calculate the new mileage based on these new local variables, because new mile and old mile are local to this module. These other variables up there, they're local to the input mod. I'm done with them. Garbage collection is going to kill them. Once I have mileage, I'm going to use the same logic to test it. I'm going to put an else in here now. Okay, and also what I'm going to do is if it's true, I'm going to put a call to the output mod, and I'm going to send it this change oil variable. All right, so it's going to get sent the word yes. So output's down here. It's expecting to get some information from anything that calls it. In this case, it was processing. It takes the 1 parameter that was sent, change oil, and it stores it in a variable called change oil. It sets the global truck ID variable because it's going to use truck that we set back here in input mod. And then it's going to print oil change is. I've got from the processing module a yes or no, if it's actually going to need an oil change or not. And then the global variable truck ID is waiting out there for me to use, so I'll use that to print this final statement out that says whether or not it needs oil. So down here, if I run this, it's going to ask me for our original mileage, which is going to be 1,000. The new mileage, which is going to be 5,000. This means it qualifies for an oil change. Truck number 5, and yes, it qualifies for an oil change. But I have to check it for no oil changes also to make sure that the logic is correct. So I'm going to run this again. And I'm going to make this 1,000 again. I'm going to make the new mileage 1,500, so it's only gone 500 miles. It's going to be truck number 3, and it is not needed. No oil change is needed for this particular vehicle. So what I've done is included both the Python program code, and also inside that Module 3 folder of Canvas. So you'll be able to look at all this stuff. And one of the things that happens with models versus implemented code is the model is kind of a real-world situation that hasn't really been fully tested. So what does happen a lot is when you actually get down to creating the code to complete the application, changes do happen. So if you were to look at my final Python code and compare it to some of the stuff that was in my initial models, you might see some subtle changes. The basic structure is still there, but there were some changes. I changed the names of the modules. I had global variables in there, which really weren't in any of my models at all, because that's a Pythonism. Well, actually, it's not just Python. It's all languages have global and local variables, but my model didn't really accommodate that easily. I probably could have put it in there, but I did not. And hopefully what this does, it shows you how you would walk through, at least up to chapter 5, the process in developing an application in a programming language like Python. Now, we didn't really talk about coupling and cohesion, although we are working with modules here. Coupling and cohesion really improve the usability and the function of your modules. I think probably just looking over the book is good enough for that. If you have any questions specifically on that, I think that probably Sprinkle goes a little farther than a lot of beginning classes in terms of telling you what kind of coupling and cohesion is taking place. That maybe is a little bit more than we need to know for now. But certainly those concepts are important in terms of developing modules that are reusable and are going to be of high quality. So if you have any questions, please let me know in Canvas, send me an email, and see you online.